All right, so this is just going to be a introduction to our C7 concept, which is going to be chapter 8 of the textbook. And in chapter 8, we're going to be diving into the last chapter of, I guess, half the semester. So the way this works is this course is divided into two, maybe three, but let's just take two for now, two halves. So the first half is going to be dealing everything in DC. And the second half is going to be dealing everything in AC. So we are actually, where are we right now? We are at the very last chapter of right before the halfway mark. So right before we transition everything over to AC. Now, what this chapter should, one of the main things that you should really get out of this chapter is knowing how to solve for RLC circuits. So if you were to just conceptualize what have you learned from chapter 1 up to this point, chapter 1, we looked at just it was essentially a basic review of some of the things you've learned in prior classes, specifically physics 2. We looked at Ohm's law, Kirchhoff's law. These are the strategies we use to solve very basic, very simple circuits here. Then we moved into learning some theorems. So we looked at Thevenin and Norton's, and we also looked at some other strategies we could use to help us solve for more complicated circuits. We looked at op amps. So what's an application of all these things? We moved to chapter 5, which is going to give us our devices or op amps to be able to actually start making these a little more applicable, a little more practical there. And then we moved on to chapter 6, where we talked a little bit about capacitors and inductors. And when we talk about capacitor and inductors, we're now starting to bring in some non-linearness to things. So while the prior chapters from 5 and back was all about just resistors, because of Ohm's law and because there's the nature of it, and we're just idealizing it at this moment, resistors really, we can treat them pretty linearly. But then chapter 6 is when we start we begin to add a little bit of nonlinearness to our circuits. So it's no longer straight lines when it comes to looking at circuit behaviors. We start seeing curves and everything. So with the by throwing in a little bit of calculus, looking at time constants and everything, we exponentials and everything, we start to see a little bit of nonlinearness coming in. Chapter 7. Introduction to first order circuits. So we started looking at RC, RL, because with the moment you start adding these capacitors or inductors, these energy storing units into your circuits, you're going to have a more complicated version of what you saw in chapters 1 through 4, because 1 through 4 only dealt with resistors. Chapter 6 now, you're now including energy storing elements, just a single capacitor, a single inductor, or there's a way to reduce it down. Now we're at the finale of things. Second order circuits, where we are now looking at multiple energy storing units within your entire circuit. And then we need to figure out how to solve for these. So that's kind of how we're scaffolding things up. So just wanted to bring that introduction out to everyone so that so we can kind of see conceptually where are we in circuits. So chapter 8, we begin with RLCs here, and this is just the ebook, and I just wanted to use this because it has some of the relevant information that we need here. So I have these circuits, and basically these circuits are examples of RLC. Very simple forms of them, but essentially what defines a second order circuit? You have two storage elements, as you see here. So you have so you have at least two different storage elements, and each of the storage elements, there isn't really a way to combine them. I know that there are some tricks to combine capacitors and inductors, but in this case you won't be able to. So you have to deal with it. So how do we solve for them? And here are some examples of second order circuits. So you have your RLC in series and parallel. You have double inductors, but because of the resistor, that exists between them, you can't really combine them. And here you have a capacitor, but you have a second capacitor that has a resistor that kind of blocks it, quote unquote. So you can't really treat it. You can't really add the capacitors together in this case. So you have what exists are two energy storing units. So by definitions, the second order circuit is characterized by, it's essentially a second order differential equation, which is what we're going to need to solve for. And our goal is to be able to figure out methodology to solve for these circuits. So really, in a nutshell, what's really happening here? You first need to look at the initial conditions of the storage element. So again, if you recall what we've learned in first order circuits, that's very similar. That's a similar beginning step. We need to figure out what the initial conditions of the storage elements are. And even though there's a dependent source that's included or involved, you treat them as if they were source-free. That's why it was important for us to identify source-free type of circuits, so first source-free first order circuits, because we needed to know how to solve for these initial conditions. Then after, when some sort of switch activity happens, the circuit turns on or turns off, there's some excitation by the independent source. So now there's some involvement there. And then it'll give what you call a transient response and a steady state response. Transient response, think of it as it's like the revving up period. So you need to rev your engine up, eventually up to stabilize at 60 miles per hour or whatever. So transient response is that period where you go from switch activity to steady state condition. Usually if you have some sort of times constant, for example, we can assume that after 5 time constants, we've hit steady state for your storage units. So we need to identify what those two periods are, the transient and the steady state response. And then that's where we can set up that's the end of a majority or a big part of setting up your equations here and setting up just the values, characteristics, behavior of your circuits. And then from there, we can apply them into other means. So I would highly recommend that everyone look through the textbook as a guide, because second order circuits, it's going to be pretty long. As you've noticed, there are a lot of these shorter pre-lecture videos that we're expecting you to watch. So make sure that you check those out before we see you in class.